Let's go together over the use of the periodic table to write down the electron configuration. The periodic table can be divided in 4 blocks: S, P, D, and F. You will see here on this picture how you can divide the 4 blocks. So we have the S block on the far left, the P block on the far right. In between, we have the D block, and the F block is underneath. What we can do is we can use the periodic table to determine the energy sublevel filling sequence. You will start from the top left corner of the periodic table, and going from left to right, you will start writing your electronic configuration. There's few exceptions to the rule that are highlighted here. And these exceptions to the filling sequence rules are not shown on the periodic table. This is the case of copper and chromium. But again, what I want to mention is to not worry about remembering these exceptions. Instead, just focus on understanding the general trends. I would like you to remember as well that the main group number gives us the quick reference to identify the number of valence electrons in a main group element. For that reason, any element that belongs to the group 1A main group number will have 1 valence electrons, and so forth. Be mindful as well of another notation called the noble gas notation. In the noble gas notation, you will use the representation of the noble gas. The inner electrons will be represented with the symbol of the noble gas in brackets, followed by the outer electrons. And within the outer electrons, I want you to remember that only the valence electrons are those that belong to the sublevel S and P. D and F orbital electrons are just outer electrons. They are not qualified as valence electron. So let's practice the use of the periodic table to write the noble gas notation electron configuration for the atoms below. We're going to start with oxygen. Before we do this, just wanted to remind you, that we have here the first 2 columns. This is our S block. And right here, maybe I can just go slightly bigger, it'll be more helpful. You have your P block. Oh, sorry. The electrons from the S and the P block are the valence electrons. In between, right here, the transition metals. This is here, your D block. And finally, underneath the lanthanides and the actinides, this is your F block. Before we move on, I want you to remember that on the level 1, you find only the S sublevel. On level 2, you find S and P. So P only starts at 2. On level 3, you will find S, P, and D. So D only starts at 3. And level 4 and above, you'll find S, P, D, and F sublevel. So F only starts at 4. Really wanted to emphasize that S starts at level 1, P starts at level 2, D starts at level 3, and F starts at level 4. Why is this helpful? This is actually helpful in understanding how we're going to fill the sublevel. So let me just delete this now and go back so you can understand. So if this is the S block here, the first two column, okay, then I have here the 1s because S starts at 1, 2, 3, 4, 5, 6, and 7. Then I'm going to go in the P block on the right side. P starts at 2, so I start at 2. 2, 3, 4, 5, 6, and 7. D starts at 3, and I know that the D block is in between the S and the P block. So here's my 3D, 4, 5, 6. And then what do I know? I know that the F block starts at 4. So here it's 4F and here is 5F. This is the best way to remember, okay, how can we actually use the periodic table to determine the energy sublevel filling sequence. And again, we're going to start from the top left and you're going to go to the bottom right, the same way you are to read the page of a book. When you do this, you have to remember that the F block, this block here, is actually located right there. So when I enter, let me just take another color, but if I enter this line, I need to first go through this line here before I can go to the 5D. So that's why I will fill the 4F after the 6S, but before the 5D. Very similarly, if I enter here, the 7S, I need to go through the 5F. Sorry, if I enter the 7S, I need to go through the 5F before I can enter the 6D. Okay, really wanted to remind you of this. So now that we have done all this, we can start reading our electron configuration. Let's do our first element. So we have to do oxygen. So I'm going to get rid of everything that is not useful. And because I just want, we're going to look at oxygen. We want the noble gas notation. So be careful. You want the noble gas notation. Therefore, what you have to do is start reading from the noble gas of the line before. So we're doing oxygen, right? The noble gas before is helium. So I'm going to start reading at the end of this line, helium. And then to reach oxygen, I need to cross 2 boxes of the 2s and 1, 2, 3. You're going to land in the 4 box of the 2p. Therefore, 1, 2 for the 2s, 1, 2, 3, 4 for the 2p. Your configuration is bracket helium 2s2 2p4. Let's take a look now at the next one. Let's do magnesium. Magnesium is located right there. We want the noble gas notation, so I'm going to look at the line before, and at the end I see neon. If I want to reach magnesium, I have to cross 1, 2 boxes of the 3s. So 3s2. Let's keep going. We want to do silicon now. Silicon is right here. The line before the noble gas is neon. To reach silicon, I have to cross the 3s 2 times and the 3p 2 times. 3s2, 3p2. Let's keep going. Vanadium now, right here. The line before vanadium, I have the noble gas argon. So this time it's going to be argon. And then to reach the box that contains vanadium, I have to cross the 4s 1, 2 time and the 3d 1, 2, 3 time. Therefore, vanadium will be 4s2, 3d3. What about zinc? Then let's do zinc together. Zinc is located here. The noble gas before, the line before is argon again. But this time, if I want to reach zinc, I have to cross more boxes. So I have to cross everything here, meaning that I'm crossing again the 4s 2 time and the 3d 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4s2, 3d, 10. And we were doing zinc. We already did vanadium. What about bromine? Right here. Again, I go the line before at the end, and it's argon. In order to reach, I need to cross all of these columns. This is the column of 4s, 3d, and the 4p. 2 in the 4s, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 in the 3d, 1, 2, 3, 4, and 5. 5 in the 4p. What about rubidium, Rb? Well, let's take a look at this one together. Rb is right here. The line before is Kr, krypton. And then I need for Rb to just barely enter the 5s. Therefore, krypton 5s1. We keep going and then we can do the next one, palladium, right here. The line before, at the end, I find krypton. To reach palladium, I'm crossing the 5s and the 4d, 2 times the 5s, and 1, 2, 3, 4, 5, 6, 7, 8 for the 4d. Let's do lead. To do lead, the line before, it's xenon. But here, remember that this block, the F block, is here. Okay? Therefore, in order for me to reach lead, I'm going to enter here the 6s, and then I will go down to the 4f before I can return here to the 5d. Again, I enter the 6s, then I go to the 4f before I can enter again the 5d. 2 in the 6s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. In the 4f, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the 5D. And here is my 6p, 1, 2 in the 6p. Do not forget that here, that's your p block in orange right there, okay? And in yellow below the F block. Let's finally do our last one, uranium. If I want to enter the second line of the F block for uranium, it means that to reach U, I need to enter here. Therefore, the noble gas before will be Rn. And then I'm going to enter the 7s 2 times, 1, 2. And then for the 5f, I cross 1, 2, 3, and 4. So here you have multiple electronic configuration, all in the noble gas notation. What you might have to do here is to identify the inner electrons and the outer electrons. So if we want to identify first the inner electrons, well, it's fairly easy. Those are your inner electrons. In noble gas notation, the brackets represent the inner electrons. These are your outer electrons. Together, they represent the total number of electrons, which is, in the case of a neutral atom, the atomic number. Among the outer electrons, you will find the valence electrons. Remember that the valence electrons are parts of the outer electrons and are only in the S and P sublevels of the higher energy level. I'm going to circle the valence electrons. Here, oxygen has 2 plus 4 equals 6 valence electron. Oxygen belongs to group 6A. Magnesium, 2 valence electrons, group 2A. Silicon, 2 plus 2, 4 valence electrons, group 4A. Vanadium, only 2, okay, because the higher level S and P only, so only the 2 electrons in the 4s are the valence electrons, 2 valence electrons. The group number equal the number of valence electron is only true for the main group elements. Okay, vanadium is a transition metal, so it doesn't work. Same for zinc, only 2 valence electrons. Bromine, 2 plus 5, the 3D, it's 3D10. These 10 electrons are only outer electrons. The valence are only in S and P of the higher level. 2 plus 5, 7 valence electrons, 7A. Rubidium, 1 valence electrons, 1A. Palladium, transition metal, 2 valence electron. Lead, 2 plus 2, 4 valence electrons, group 4A. Uranium, which is an actinide, so only 2 valence electron, doesn't belong to the main group element. I really hope this helped you to understand better how to use the periodic table to write down the electron configuration. Thank you for listening, and do not forget that you can always reach out to me or your SI leaders if you need extra help. Thank you. Bye-bye.